Hey everyone. Can you hear me? Is that good?
Yes.
Yeah. Okay, so yeah, my name's Richard Blythman. I've kind of been adjacent to the DeSci space for quite a while, probably around 3 years. Um, and DeSci has been really good to incubate the decentralized AI space for quite a long time. A lot of the DeSci conferences have had, decentralized AI events and that sort of thing. This is when the decentralized AI space was really small. And now it's kind of crazy in decentralized AI. I don't know if you've seen a lot of the events that are going on, but it's really becoming its own thing and it's really exciting. But yeah, so we're mostly in the decentralized AI space, but also have always been passionate about DeSci. So today I'm going to talk about building a platform for data generating agents. Okay, so I've kind of gone back and studied the history of AI platforms. Of course, a lot of them are centralized. So first of all, what is an AI platform? It's a place that allows individuals and companies and governments to share, discover, and consume AI assets. To build an AI platform, you actually need a collection of technologies. And I think that's why it's taken so long for decentralized AI to become a thing, because we've had to implement all of these technologies that are lower in the stack. And now we're getting to the point where we can put all of them together to do some cool AI applications and that sort of thing. So I'm going to talk about some of these different technologies today that make up a decentralized AI platform. I'm also going to go through the history of some of the previous generations of AI platforms and talk about, some of the disadvantages of centralization, as well as the advantages. So the first kind of generation of AI Hub was GitHub, right? This was a place for storing code related to AI. GitHub, of course, is still used. But like one of the downsides of GitHub is that you can't upload model weights and data sets, right? So they just don't provide the storage space for that. The assets can be open source, but the actual platform itself is closed source, like the index or the data layer, right? The fact that you couldn't upload model weights and data actually left an opening for the next generation of platform, which is Hugging Face, which I'm sure a lot of you have heard about. So they call themselves GitHub for AI, right? And not only can you store code here, but you can also store data sets, model weights, and they even allow you to build apps now as well. Again, the assets are usually open source here. Hugging Face has a really big open source ethos, and they've contributed to the community quite a lot. But still, it's a closed platform, right? The index or the data layer is completely closed. And so if someone wants to build a new front end on top of this index of data assets, they just can't do it, right? I should also say, there's this distinction between different generations of software as well. So software 1.0, as it's now called, is kind of just what we think of as traditional software, like code. People have coined the term software 2.0 for machine learning models, because rather than kind of writing the code manually, you basically just provide a data set and then you learn the mapping from the input to the output. So it's like a new way of writing software. Don't write the software, just get the data set and let the software kind of write itself, right? Okay, so I want to take a quick detour to talk about the next generation of platform that has just emerged recently. And it's kind of built around this idea of prompt engineering. So this is what most people think prompt engineering is in the top left. If you're using Stable Diffusion, you have to say Ultra HD, 4K, basically beg your model to output exactly what you want with a lot of words. So people were quite critical about prompt engineering at the start, saying, it's not going to become a thing. But I think prompt engineering actually isn't a great term. I thought something like LLM systems engineering is a better term, because not only are you doing prompts, but you're also kind of managing memory, and you're writing to databases, and it's kind of like these workflows, right? And more recently, a new term has kind of emerged, which is AI engineering, which is kind of a combination of prompt engineering and kind of workflow engineering and that sort of thing. Let's stop working. Oh, here we go. Okay. So what is LLM programming? Well, it's doing programming on top of LLMs. So some of you have probably played around with this before. The kind of main thing that I would say about LLM programming and the main difference with machine learning is that the model is now just one component of a larger system. So it used to be the case that the model was the whole system, and all you really did was train the model. Now the model is one component of the system, but you also have other components. Like, for example, you have like what I call short-term memory. So anything that goes in the prompt context window, we're getting pretty big context windows of like 16K or like even like a 1 million context window was released recently. So you can kind of store information in that context window, usually in like a dict data structure. There's also like long-term memory. So you might have heard of like vector DBs and embeddings. This is a place where we can store different data that the LLM can then retrieve from. And also we add like tools, plugins, skills to the system. So you can allow your LLM to use a calculator because LLMs aren't that good at maths, or you can even allow them to use like simulators. So you could give your LLM access to like some sort of physical simulation tool, really anything, or it could just be like an API or something like that, right? So yeah, that's pretty much how I think of LLM programming. Like a big part of it is kind of like management of memory. So like maybe this isn't as much of a thing now, but you have to like manage the context window and what was kept in it and all that sort of stuff. So it's kind of like an operating system in a sense. Okay, so why are LLMs so different to the machine learning models that came before them? There's kind of like three big reasons that I always give. These kind of new abilities that just happen to emerge when we train models above a certain size. So the first one is in-context learning. And this kind of allows LLMs to personalize on the fly. This is why retrieval augmented generation, which you might have heard of, works, called RAG. So we can basically, so how we used to pass data into the model was we would, do a training procedure. We would pass the data in through the model weights, and then we'd update the model weights a little bit in the right direction and do this like, lots of times. There's a new way to pass data into models, which is just in the prompt, right? So we're passing data into the model in the prompt window. We're not actually updating any of the weights, but by using this data in the prompt, we're actually like personalizing the behavior of the model. This actually is like surprisingly effective. So there's a bunch of like really interesting papers that find that, for example, if you run an LLM and do in-context learning, in other words, putting data in the prompt window, it can actually be competitive with like federated learning solutions. The issue with federated learning is that you need a lot of data. With this kind of in-context learning, you actually only need like a few samples and it works really well. So it's like a new kind of paradigm of personalizing models. So that's one reason. Another is like better generalization. So, before models weren't as good at generalizing, I guess. So anything that was kind of outside of the distribution of the training set, it really struggled with. The funny thing now, you'll probably notice it from playing around with ChatGPT, is that you can ask it a question that is really, really specific to a certain area, and it does surprisingly well, even though, probably it wasn't trained on that. So we've achieved better generalization with these larger models. The last one is probably the most interesting, I think, for DeSci. And this just emerges with models above a certain size, and also from training on code, I guess. That was like a bit of a discovery. But we can ask LLMs to like do these like kind of reasoning steps. Whether it's actually reasoning is like kind of up for debate. There's different definitions, all that sort of stuff. But what people found was, for example, if you look at the image on the right-hand side, if you just ask the LLM a question, it'll like answer in one go and maybe get it wrong, right? But if you ask it to kind of think step by step or like break down the problem into steps, it actually works through it. It shows its workings and it's more likely to get the answer correct. So what we're kind of doing here is like using more inference steps of the model, more computations to give it a better chance of getting the answer correct. And this is just something that like the previous generation of models couldn't do. So that all kind of leads me to like this next generation of AI platform that we're starting to see. Probably the most well-known example is OpenAI. So they started off by just building models, but now they're starting to build a whole platform around it, right? So they have like the playground for playing around with their different models. They have an API. They then released like ChatGPT, which is this like was originally just a proof of concept, but got really popular. They experimented with plugins. So what are plugins? They basically allowed any like third-party service provider to build a plugin for OpenAI, which meant that when you're using ChatGPT can actually call that API. So for example, Expedia, the travel site, made one. They made a plugin for OpenAI, and then there were like some cool demos where you could use ChatGPT and ask it to book a flight for you, and it would use the Expedia API and book that flight, right? So yeah, there's like a risk here, right? Because there was a blog post at one stage talking about is ChatGPT going to become the super app, basically? Because if every app builder needs to build a plugin for OpenAI, and all of the access to those apps happens through ChatGPT, ChatGPT is effectively a super app, right? Like if I want to book something on Expedia, I go to ChatGPT. If I want to book groceries, I go to ChatGPT, and then ChatGPT just goes to the other apps for you. So that's kind of a risk here in terms of centralization, I guess. Unlike the previous generations of assets, generations of platforms, GitHub and Hugging Face, where the assets were open, all of the assets are closed on OpenAI, right? You can't see the open source code for your GPT assistant or whatever, or you can't download it. And of course, the index and data layer is still closed. So OpenAI, like maybe a little bit scary in terms of like centralizing AI and power and all that sort of stuff. I think this one is even scarier. So Palantir kind of released an AI platform based on LLM programming and LLMs as well. You can see it on the right. It does all the same stuff. It has like data, models, workflows. The terrifying thing about this is that Palantir do a lot of work for like military and governments, and they even released a proof of concept of ChatGPT for war, which is in the bottom left corner. So you can chat to your army like you would chat to GPT, move them around the battlefield, tell them to kill people. What could possibly go wrong, right? So you can tell that I'm kind of biased against decentralized AI platforms, right? I think they've done huge amounts of benefits to like the AI space and society, but they have downsides that we've seen. A lot of the ones that we're common to we often talk about in the Web3 space, right? So like lack of privacy. If our data is on these platforms, there's already been data leaks from OpenAI, for example. What happens when we start to connect ChatGPT to all of our other apps? We connect it to email, we connect it to all of our personal data, right? That's a big question. Also the lack of ownership, right? So this happens on like Hugging Face. Open source contributors upload assets to the Hugging Face platform. Sometimes Hugging Face actually sell these assets in their consultancy services, and they don't reward the people who uploaded the assets in the first place, right? So you have like a lack of ownership, and you also can't monetize what you build on these platforms as well. Lack of transparency. We can't see the index, the data layer, like what assets are used, all that sort of stuff. There's risk of deplatforming. So like one example of deplatforming was like to a GitHub repo. There was this open source developer. He was kind of sick and tired of big tech companies building on top of his open source code and not rewarding him. So he changed. He like introduced a bug to it, and then GitHub locked him out of his accounts and put the changes back, right? So whether he was right to put a bug in his code is like up for debate, but it just kind of shows that GitHub can lock you out of your accounts whenever they choose, right? Monopolistic practices. So like I didn't talk about these AI platforms, but AWS and compute platforms are kind of another type. And 3 companies make up 2/3 of the market share, and AWS makes 60% margins on the compute. So it's monopolistic pricing, right? And a huge amount of that goes to startups, right? Think of the startup expenses that are paid for AWS, and they're taking a bigger cut than they could be. And of course, there's a lot of decentralized compute projects in the space working on this. The scariest one is surveillance, right? Yeah, there's like a lot of governments in the world that are trying to build AI platforms to like surveil the population. I actually worked for Huawei. I've seen this firsthand. It's part of the reason I quit and came into the decentralized AI space. But it's not just China. Like a lot of this happens all over the world, like in the US and that sort of thing as well, right? Okay, so yeah, the Web3 space has been building a bunch of technologies that can potentially help to mitigate some of these issues. So yeah, this is my like V3 version of the decentralized AI stack. I first created it in 2022, and back then no one was really talking about like putting all of these technologies together. And so like I've kind of separated it into 3 like broader categories. You have like the infrastructure layer for like compute and storage. Then you have like the data layer. There's a bunch of you can break that down even further, and then you kind of have the application or intelligence layer on top. So the compute and storage, you'll be familiar with all of the projects like IPFS and Bacalhau and Filecoin. In the data layer, you'll see what I call indexing, which are things like Ceramic. So Ceramic build like indexes on top of IPFS. ComposeDB is like is really cool. Can we use Ceramic, ComposeDB, and IPFS to build like an open data layer for Hugging Face? I think is a really interesting question, kind of like DeSci Labs have done for research objects, right? I think that's quite a similar problem to solve. There's like verification stuff, so people doing like ZK verification or like data verification with Chainlink oracles, right? There's kind of the marketplace layer, or like what I'm now calling payments and access control, because marketplace is quite a broad term. So you have projects like Nevermind here and Ocean. There's a bunch of like privacy preserving technologies like fully homomorphic encryption, like OpenMind and Zama. In the intelligence or application layer, we have a bunch of like LLMs here, which could be super helpful for building platforms. There's like training and inference kind of compute providers. Jensen is like one of the really well-known ones there. Then we have a bunch of like agent frameworks coming out. So like Olus, Morpheus, you might have heard of at this event, just kind of like launched and came into the space. And yeah, there's a bunch of like AI assistants, and that's sort of, so for example, Brian Knows AI and Polywrap, they both build chat assistants that are like really good at interacting with Web3 tools, for example. So they can like interact with your wallet and all that sort of stuff. So these are kind of like apps that are built on top of the decentralized AI stack. And then there's like my new project, Napta AI, previously Algovera, but we're basically trying to like put a lot of these different things together and like do build applications and also like orchestrate different applications and agents and all that sort of stuff. So yeah, that's the decentralized AI stack. And I think we can use a lot of these technologies to build a new type of AI platform. Yeah, this is just like going over some of the R&D we've done previously as Algovera. We've worked with a lot of the different layers on the stack. So we actually built the IPFS Python libraries. We built this thing called IPFS Spec, which allowed us to integrate with Hugging Face platform and use IPFS storage there. We built IPFS Pi. We also built an integration of IPFS with another hub that's called Active Loop, which is usually used for more like computer vision data sets. We've worked a ton with compute. So we worked with C2D, compute to data, like maybe 2 years ago. And we, tried to do like kind of workflow orchestration. So C2D originally, you could only run like one algorithm on one data set. What if you want to do like pipelines or workflows? That's kind of, we did some integrations on that. We've worked with the Bacalhau team. We've worked with the Lilypad team. In terms of like access control, we've like worked with Lit Protocol and Nevermind. We worked in the Ocean protocol ecosystem for a long time. And more recently, we've started working with Olus, Autonomous or Valerie on agents and agent frameworks. So yeah, like what we've kind of done now is like put all of our learnings together into like an AI node, which was like partly inspired by DeSci nodes from DeSci Labs. And me and Chris chatted a lot about like what AI nodes would look like. Basically, it puts together a bunch of different technologies that you need to, run AI applications locally and in a decentralized way. So it puts together storage, compute, payments. There's like a local LLM that runs on your laptop as well. And we do a bunch of like orchestration around tasks. So you can have an agent that runs on your laptop, performs tasks using the local LLM, gets paid for it. Like, yeah, a bunch of different applications that we can build. And we're going to be launching private beta in the next few weeks, and then eventually like open sourcing this for everyone to use. So I want to talk about some use cases. So that was the title of the talk, was like data processing agents, right? So what kind of brought us to that as a use case? We started off just trying to build chat assistants. So one of the products we built was kind of like similar to how building your own chat assistant on OpenAI looks recently. I think they just launched it at OpenAI Dev Day. We started working on it, I don't know, six to 9 months before. Stopped working on it when we realized probably OpenAI were going to build the same thing and eat our lunch. But yeah, we basically built this like platform for building your own personalized assistants, right? At that time, we ran it on AWS just because the performance has to be like really fast. If you're interacting with a chat assistant, people expect really, really fast response times, right? So it's just not possible to do that on decentralized compute infrastructure yet. And yeah, there were no like open source models back then, so we just used GPT. But I think there's like a bunch of stuff that could be done here to build like an open decentralized version of the GPT store. I think that's totally possible with the technologies that we have today. one of the projects that we built something for, we built like a coding assistant for Chainlink. We built this assistant that uses like, I think it was like 15 to 20 different data sources from the Chainlink ecosystem, like their blog, their docs, even like some Chainlink Oracle data sources, a few papers, blog posts, all that sort of stuff. And we built this like personalized Chainlink assistant that, devs they could interact with, if they wanted to do some coding with Chainlink or something like that. So as I mentioned, like the real challenge here is like real-time performance, and that's kind of why we moved away from it. Maybe it can be solved, but I also don't think it's the easiest thing to solve if you're running on top of decentralized AI infrastructure. So what we then moved towards was like more things that can happen, in non-real time. So, can happen in the background. One of the first things that we built with Nevermind was like a research summarizer agent. It basically like it monitors archive, it like downloads new papers, scrapes those papers, and does some sort of data processing on top of those papers. So maybe generates a summary, extracts the key points, the key insights, all that sort of stuff. And that's something that doesn't need to be real time, right? You could just, run this once a day or something when new archive papers come out. It's also a use case that's really hard to do on centralized AI. Can you imagine what the GPT costs would be if you like processed every single research paper that comes out on archive every day? It's absolutely huge. Whereas if we can run this on, idle compute on laptops, that is something that I think is manageable. We built some like researcher agents for Ocean Protocol. I don't know if you've seen Ocean release this thing called Predictor. They're trying to basically predict the price of like Bitcoin and ETH. You can use kind of traditional machine learning models, but one of the things we tried was like monitoring social sentiment on social media. So can we read like a bunch of Twitter posts that come out in real time? And then we have these researcher agents that do some sort of analysis of those tweets, and then use that to make a trade or make a prediction on these markets, right? We also built something like researcher agents for a project called Delphia. They're like a Web3 hedge fund. And that was, the idea there was they want to like find projects that they can make investments in, I guess. So we would read like a bunch of opinion pieces from analysts who would talk about certain like stocks or something like that. And then our researcher agents would kind of analyze that, try to extract the key insights that that analyst was saying, build like almost like a discourse graph of like claims and evidence for those claims and that sort of thing, and then construct a knowledge graph with that. So that was another kind of like data processing thing, and that's another example of something that can run in the background. Of course, like imagine how many articles on stocks and stuff come out every day. That would also be super expensive to do with GPT, right? And same, of course, for Twitter social sentiment. How can you analyze every tweet with GPT? One of the ones that we're working on at the moment is something like researcher agents for prediction markets. So yeah, there's these prediction markets on Gnosis. They're called like Omen. Prediction markets, people always talk about them as having like a bunch of really interesting use cases, but actually it's really expensive for humans to like take part in these prediction markets, and they haven't got a lot of traction, I guess it would be fair to say. So what Gnosis and Olus started doing was saying, well, why don't we like get bots taking part in these prediction markets, right? So one of the researcher agents that we built, it basically like looks at the question from the prediction market, like, will a certain event happen before a certain date? It generates search queries, like that we want to use with Google. It gets the results from those search queries, it like scrapes the data, it analyzes that data, processes the data, does reasoning over all of the different data, and then makes a prediction on the prediction market. This is something that Olus are really pushing for now, which is like maybe a good use case for decentralized AI, which is generating synthetic users for Web3 ecosystems. There's a bunch of protocols that want more users. And in Web3, you can't tell if a user is like a human or a bot on chain, right? So why not just generate users using bots, get more transactions, all that sort of stuff. So I think like a lot of L2s, like we met with Optimism, for example, that are interested in bringing more bots to their chain. Also like Arbitrum and stuff, right? So yeah, that's also something that doesn't need to happen in real time, right? So yeah, like what I've always been most passionate about, and it's why like I kind of hang around the DeSci space. I come from a research background. What I've always been really passionate about is like building autonomous research systems, right? So this is like from a paper called Simulation Intelligence, I think it's called. It's like really long. It's maybe, I don't know, 80 pages or something. But it's super interesting. They talk about, this was pre-LLMs as well. They were talking about like systems for autonomous science and all of the different models and components that we need to put together to do that, right? I think we can build this. Like LLMs have opened up, like they've like pushed the boundary of what's possible with respect to autonomous research, and I think that's super exciting. And I think there's still like a bunch of work to be done here. I think like all of the capabilities of LLMs are gonna diffuse through science for probably the next 10 years. There's a bunch of stuff to build out here, and who knows if we'll get all the way to autonomous research. Maybe there's some limits to LLMs, right? But we can definitely get further than where we are now, which is super exciting. Yeah, this is like a really rough first version of our front end. I just started front end recently. I'm also not a designer, so we need to get a designer in. If anyone knows one, send them my way. But like, yeah, we're basically trying to build this new type of platform that runs on top of decentralized infrastructure, right? So this is a view of our app, which shows like some of the different compute nodes that are running on our network. We have different compute nodes for different members of our team. Maybe in future we'll have like compute nodes run by some of the organizations that we're friendly with. So you have all of these different nodes that can run computations, and then you have this like library of workflows that can run on top of these nodes. And so we provide templates, for example, for like researcher agents, some of the ones that I've talked about before, prediction agents, all these sorts of maybe research summarizer agents. We're going to provide a bunch of templates for that, and then compute nodes that join the network can basically run these templates. And it runs on like laptops. So if you want to just like run your researcher agent overnight on idle compute, all you're paying for is the price of electricity, right? So the kind of goal is to build up this like big network of nodes that can run a lot of these researcher agents offline and do things that centralized AI platforms can't do, for all the reasons that I mentioned, because it's like too expensive to analyze all of the archive papers or all of the tweets or all of the articles that come out every day. If we build this decentralized compute network, we can have a massive network of data processing agents and start combining that data, and who knows what that can get to. Okay, so yeah, just to kind of sum up, yeah, a lot of the existing AI platforms that we've seen to date use centralized technologies for understandable reasons. Like decentralized infrastructure has been, super early. Centralized technologies have certain benefits, like better performance, and also limitations. Some of the ones that I mentioned. Decentralized infrastructure that we're seeing now are maturing a lot. Decentralized compute has come such a long way. Decentralized storage, even like payments infrastructure, like with account abstraction and stuff, it's just much more usable. We're really getting to the point where I think we can build these AI platforms on top of decentralized infrastructure technologies. However, there's certain use cases that are more interesting. Real-time applications that require real-time performance, like chat assistants, are still challenging. But I think data processing agents are like a really good use case of this decentralized infrastructure, and also super relevant for like science and research as well. So yeah, that's it. If you want to chat more in future, like reach out. We'd love to collaborate. We'd love to work with more DeSci projects in the space. Question.
So you mentioned that the Napa marketplace, the agent marketplace, you mentioned a lot of the use cases of agents that would run sort of whilst you're offline, for example, or they want to not good. If you wanted to run your own personalized chatbot service, would that also apply to Napa?
Yeah, that's a really good question. So, yeah, I think like how I see the nodes that are going to run locally on the laptop is that maybe you don't even need to go to the network, right? You have your LLM locally, you want to increase your own productivity, you're definitely going to be able to do that, which is like run your LLM locally. And in that case, chat isn't that difficult because the LLM is right there. You can run it super quick.
So if I had a chatbot service that I wanted other people to access, say for example, I just never mind paper gateway, would that also be able to list on this?
Yeah. So you can kind of provide services to the network. You can either like upload the code if you're happy for that to be open source, and then other people can run that on their own nodes. Or I think we'll probably support a case where the code is private. Like you want to keep that as your IP, but you can still provide that service to the network behind an API or something like that. Yeah. Yeah, it's a really good question. some of the compute projects have done this, like Jensen, kind of have analyzed how much they can reduce the price of compute and that sort of thing. I think for a cache, for example, I think it's like 40 to 60% cheaper than centralized platforms. I've heard people say even higher figures than that. And in one paper, I think someone estimated that the cost of electricity compared to what the price of compute on, say, AWS is 100x. So the electricity is like 1/100th of what you actually pay to AWS, right? So that's kind of like the upper limit of how much we could reduce it. We probably can't reduce it that far, right? Because people need to get paid and there's other infrastructure that needs to be supported there. But yeah, that gives you an idea, I guess.
So that's more focused on the process. What about the storage? The IP storage solutions? It's cost. Is there at all?
I've seen some estimates from IPFS and Filecoin here. I think they did some work on this. I can't remember off the top of my head how much they think they can reduce the storage costs, but if I remember correctly, it's significant. And I guess like being more interested in the AI platform as a whole, at some point we'll need to figure out across all of these different layers, like how much can we reduce the storage cost, how much can we reduce the compute cost, how much can we reduce payment provider cost or whatever. So that's an analysis we still have to do.
So to the point that was made earlier today, trying to bring you to the States, one of the most compelling researchers startups demonstrate a significant cost comparison advantage from operating within this ecosystem and this stack. Those analyses are going to be absolutely critical to the press that we have to generate around the space to be successful.
Yeah, I think cost is a big one. I've been thinking about this a lot as well, which is like, you know, we can't just like decentralize. We can't just build a decentralized version of a product that already exists, right? That's why we haven't built the OpenGPT store yet, because I don't think it's going to have that much of an impact, right? What I'm really trying to think of is like, what are the use cases that are like 10x better than what we can run on top of centralized infrastructure, right? And I think you could apply that to the DeSci space, right? It's like, imagine this network of decentralized researcher agents that are all like processing data, combining that data into knowledge graphs, all that sort of stuff. I think that's something the centralized science space can't do. And if we can like build out something like that, I think that would be a super compelling use case for DeSci.
Considering some papers get more attention than others in like a kind of like a hype streak, you know, is there already something that, because people will be running probably LLMs to ask questions about those papers in those hype cycles, is there anything that's storing those types of those queries and results for later use, so we don't have to continually run the same questions again?
Yeah, I think yeah, that would be really interesting. I think obviously like some queries people are probably going to want to do privately, but for sure there's like queries that might be shared on like IPFS or something. And actually OLIS, the project that we're working with on prediction markets, every query that goes to the LLM is stored on IPFS as well as the response. And so you could imagine something similar for, I don't know, a DeSci use case. So all of the queries that are going to you know, asking about papers, you could store them on IPFS, and then you could build like a subgraph or something like that for people to like analyze that, do analytics, build on top of it, whatever. All right, thank you, everyone.